And for all of these, we're going to assume we are in the first quadrant for these set of problems here. Okay, sine of theta equals 1/2. That could be either in quadrant 1 or in quadrant 2, right? So not really sure here, but we're going to just assume though that we're in that first quadrant. Okay. So. What? Okay, we're going to change colors because I can't figure out where I put the pen. So, alright. So, yep, don't know where it went. Alright, anyway, so to do these kind of problems, what we're going to do, alright, is to help us out, one way we can do these, well, actually this is like unit circle kind of stuff, so we could use unit circle, but we can also use a right triangle to help us out here. So we want to create a right triangle. Create a right triangle here with an angle of theta. Okay, in it. With an angle of theta in it. Okay. And so we draw our triangle here. Okay, there's my right angle, and I'll just put theta right there. Okay. And the next thing we want to do is, with that right triangle, because again, trigonometry, right? Sine, cosine, tangent, cosecant, secant, cotangent, right? The basic idea about those things is that we're relating an angle in a right triangle to a ratio of sides in that right triangle. And then so for step 2, we don't know what theta is, but we do know that the ratio of the sides has to be in the ratio of 1/2, okay, specific sides. So we're going to fill in the sides using the given ratio. Okay, fill in the sides using the given ratio. So for example, in this situation, right, we know the sine of theta is equal to 1/2. And we know that sine, according to SOHCAHTOA, right, sine is the ratio of what two sides of that right triangle? The opposite, right, over the hypotenuse, okay? So, opposite theta here is this leg, right, the opposite leg, and so we can label that as a 1. Okay? And then the hypotenuse, right, then is going to be that 2. And then to fill in the remaining parts, okay, well, we're going to use the triangle to find those remaining parts. To find the remaining ratios. Okay, and that's pretty much it. Pretty much it. Okay, so we go to find cosine of theta. Cosine, right, according to SOHCAHTOA, cosine is adjacent over hypotenuse. So we go to the adjacent leg and we're missing what that is. But how can we find that missing leg? Pythagorean theorem, exactly right. We got two sides of a right triangle. We can use it to find the third side. So we can say 1 squared plus b squared equals that 2 squared. And so we get 1 plus b squared equals 4. Subtract 3 from both sides. B squared equals 3, and so b is the square root of 3. Okay. So again, we're starting with something familiar, the 30, 60, 90 right triangle here, but we can do this kind of we can ask this kind of question with ratios with which we are unfamiliar. So we are familiar with we have seen before sine of angle thetas that have given us 1/2, right? We've gotten 1/2 before. But we'll also see other thetas with different ratios and stuff. In the same process, though. We'll follow the same kind of process. So, cosine of theta, if sine of theta is 1/2, cosine of theta is going to be, well, √3 over hypotenuse 2. Okay, √3 over 2. And then tangent of theta, well, tangent is opposite, right, over adjacent leg, so 1 over √3. Okay, or we could say √3 over 3 if you want to rationalize it. Oops. All right, cosecant. All right, so you can either choose to use Choshikow, right, or just the fact that cosecant is a reciprocal of what trig function? Sine. So cosecant is just going to be reciprocal of 1/2, which is 2. Secant is the reciprocal of what trig function? Cosine. So instead of root 3 over 2, it'll be 2 over root 3. Okay. And then cotangent is the reciprocal of tangent. And so you can do the reciprocal of 1 over root 3 or root 3 over 3. I'm going to do the 1 over root 3 and make it just root 3 then. Okay. Alright, so let's try another one here. Okay, let's try another one here. And I'll have you guys do it once I kind of get you started maybe. So, we'll say that tangent of theta, okay, tangent of theta in this case is equal to 3. Oops, let me scoot it up some there. Alright, tangent of theta is equal to 3. And of course, then we want to find the rest. So I'm just going to write, let's see here, I'll do sine theta, cosine theta. Did I do it? Yeah, okay. Cotangent theta. I find it helpful to, like, once I've done sine, cosine, and tangent, to then write their reciprocal functions in the appropriate order. So, like, tangent, sine, cosine. I'm going to do cotangent because tangent was first. Then I'll do cosecant because sine was second. And then I'll do secant because cosine was the third one. Okay, it's helpful. You can write whatever order you want. As long as you get all 6 done, that's fine. I find it just helpful for organization's sake. Just keep my mind straight. Okay. So in this case, we'll draw that right triangle. Okay. We'll put theta in there for one of the acute angles. But then how should I go about labeling my triangle here? All I've got is a 3. Tangent's supposed to be opposite over adjacent, but all I got is the 3 there. So how can I label my triangle using just a 3? Baylor, what do you say? Yeah, exactly right. So rewrite that 3 as 3 over 1, okay? And so then opposite angle theta will be, I will label this side as what length, Baylor? 3. And then the adjacent leg I'll label as what? 1. There you go. Okay. And we might as well, right, we had 2 in the earlier one here, so we might as well go ahead and find that third side. And at this point, I'm going to cut you guys loose. So go ahead, try that. Try the rest there, okay? Get the rest of those. Sine, cosine, cotangent, cosecant, and secant of those thetas. Okay. Go ahead and find the rest of those. All right, let's see here. How about we go to Nick M. Marsico. Sorry again.
I did the Pythagorean theorem and I got root 10.
Okay, you got square root of 10 for this missing side here. Okay. And so then once you did that, what'd you get for sine of theta?
I got 3 over square root of 10.
Okay, so 3 over the square root of 10. Again, for those of you that rationalize, if you do that, right, we can multiply both the top and the bottom by the square root of 10 over 10, which would yield then 3 square root of 10 over 10. So that's rationalized. Either one's acceptable, though. That's fine. Go ahead, and then cosine, what'd you get?
Square root of 10 over 10.
So, okay, so 1 over square root of 10 or root 10 over 10. Okay, good. Okay. And then what about cotangent?
1/3.
Yeah, 1/3. That was the easy one. Okay, how about cosecant?
Root 10 over 3.
Root 10 over 3. And then root 10. Okay. Questions on anything from that? Okay. So we have, of course, some fun little twist to put on this. We can throw in some variables here too, right? So these are all nice numbers. We just get that. So we could throw in something, for example, you do something like cosine of theta, or something you could see. Cosine of theta equals something like x over 3. Okay, and all I want you to do here, we're just going to find sine and tangent. We're not going to worry about like the reciprocal trig functions, secant, cosecant, or cotangent. We'll just worry about sine and tangent. Okay. So same kind of thing, right? Same kind of thing. We can draw that right triangle, and we'll put in theta here somewhere. I just find it easy to put it down there in the bottom left-hand corner. Okay. Cosine, using what we know about cosine, right? Cosine is adjacent leg, so this adjacent leg here, we'll call that x over the hypotenuse, and we'll say that's 3. And so we need to find then that third missing side, because if we want to do sine of theta requires we know the opposite over the hypotenuse. Well, we don't know anything about the opposite leg just yet. So we'll go to our normal thing of using the Pythagorean theorem here. Same idea, same principle. So we'll say here that x squared is going to be like our a. We're going to solve for the b, okay, which will be the other leg that we're missing there, and that's going to equal 3 squared, which is 9. Okay, so we'll subtract and solve here. We'll solve for b. We'll try to get b by itself. So we'll subtract that x squared over. We're left with 9 minus x squared. Okay, and then square root both sides. And we get b equals the square root of 9 minus x squared. So b is the square root of 9 minus x squared, that quantity. All right, and so that's what we'll put right there for that missing side. Okay, so we just kind of leave it with an x squared in there. Okay, but we at least have an expression for that missing side, so now we can find sine and cosine, or sine and tangent. Sorry. Okay. So again, whatever that angle theta is, we have no idea what that angle theta is, but we can still evaluate sine of that theta is going to be the opposite leg, square root of 9 minus x squared, over that hypotenuse 3. And likewise, tangent. Don't know what theta is, we can still evaluate tangent of the theta using, you know, that right triangle there to help us. Tangent will be the square root of 9 minus x squared, sit, leg over the adjacent leg, x. Okay, just like that. Not really numbers, right? We still have the x in there and all that, but at least we can still kind of evaluate some stuff. So there's that. Okay. Questions on any of that? I'm going to give you guys one. All right, so here. Then you guys try this one. So for this one, try... This time I'm going to give you cotangent of theta equals x plus 2 over 7. And again, I just want you to find sine of theta, cosine of theta, and tangent of theta. Okay. So again, try those 3. Given that cotangent of theta is equal to x plus 2 over 7, find the sine, cosine, and tangent of that same angle theta there. Okay. root, a sum is not equal to the individual square roots added together. In other words, if you have x squared plus 10, you have x squared plus 9, you take the square root, that does not equal x plus 3. Okay? And take the individual square roots of those things. Give that one more minute here, one more minute. Okay, so using the fact that cotangent of theta is x plus 2 over 7, I went ahead and just did, right? Tangent of theta is reciprocal, 7 over x plus 2, pretty straightforward. So then theta, we make our triangle here, opposite 7 over adjacent leg x plus 2. And then to find that hypotenuse there, we're going to square out the 7 squared, a squared, right, plus b squared equals c squared. So you square them out. And you're going to get c is equal to the square root of x squared plus 4x plus 53. Okay? And so then it's just a matter of finding the cosine. So sine will be opposite, 7 over the square root of x squared plus 4x plus 53. Okay. Cosine is the adjacent leg over that same x squared plus square root of x squared plus 4x plus 53. Questions on any of those? Questions on any of that? All good. Okay, pretty straightforward. All right. One more thing I want to show you then, and we will be done. Okay. The other way we want to be able to kind of use trig ratios, the other kind of like thing that could be thrown at you, okay, is to, again, we're going to find trig ratios again. So kind of falling in that same vein as we were before, finding all the trig ratios or finding some of the trig ratios using a given information. Now we're going to find some trig ratios. We're going to be given, okay, the terminal side of theta goes through, or we could say has coordinates of -3, 4. Oops, I should probably put like has coordinates of. That makes more sense. Okay. So find the trig ratios given that the terminal side of theta goes through or has coordinates of negative 3, 4. Okay, that's what our goal is here. So we're going to find the trig ratios given that the terminal side of theta goes through or has coordinates of negative 3, 4. So a bit different than what we did before, right? Before we were told sine of theta is this ratio, and we could set up our right triangle this way. Here, though, we're talking about the terminal side of theta goes through, and it has coordinates, negative 3, 4. We're on the coordinate plane, so it might be helpful here to kind of draw, okay, a small coordinate plane here. And we'll kind of eyeball that point, negative 3, 4, so we'll say like kind of 1, 2, 3, and then 1, 2, 3, 4. So something like right here. There's that point, negative 3, 4. So where do we get the angle? Where do we get an angle if we have a point? Like where's this angle coming from? Well, the idea is that this point, negative 3, 4, is the terminal side of the angle is on negative 3, 4. So again, terminal, right? That's like a starting or stopping point of an angle. In this case, when we do angles in the coordinate plane, remember we always start our angles from that positive part of the x-axis, and our angle opens up counterclockwise from that point. So the terminal side, the ending side of our angle, is right there. So there's our theta. There's our angle theta right there. Okay. So there's that angle theta. That negative 3, 4, that location of that point, you're supposed to go counterclockwise around from the x-axis there. That then indicates where our theta is. Okay, so that's the terminal side right here. That's where that angle theta ends. Okay, right there, terminal side. But of course, we look at that angle theta, and it's like, there's not a right triangle there. That's going to be an obtuse triangle if we try and draw something maybe or whatever. But remember, right, we had situations like this in our unit circle where we wanted to evaluate this angle, but instead of evaluating the big angle here, we instead used the reference angle, so right here. Okay, so we're going to ignore that theta there. We're just going to use the reference angle theta down here and drop down like a, a side there and make a right triangle. Okay, we're going to make a right triangle here. So, using that reference angle theta now, what are the measurements of our right triangle? For example, what's the length of this part right here going to be? What's that length going to be? 3. Yeah, 3. Okay. What's this height going to be? 4. And what's the hypotenuse going to be? Right, so it's going to, we can use Pythagorean to find the missing side. It is Pythagorean triple, so what do we know the height? Well, some of you guys probably know. What's the hypotenuse going to be here? 5, right? So 3, 4, 5 triangles. So the hypotenuse will be 5. Okay? So we're not on the unit circle, right? The unit circle we would have a hypotenuse of 1 there. We're not on the unit circle, but we can still, use all of our trig stuff and all that good thing. Okay, so we have this. And so now we'll just find all of our trig ratios. Okay, so we'll say sine of theta, cosine theta, tangent theta. And then we'll do cosecant theta, secant theta, and then cotangent theta. So using that reference angle theta, using the reference angle for theta, what sine of theta going to be here? So using our reference angle here, using this reference angle, what is sine of theta going to be according to our triangle? What's that? Yeah, it's 4/5. Yeah, the opposite leg 4 over the hypotenuse of that triangle 5. 4/5. Okay. Whoops, why did I put it for cosine? Okay. What's cosine of theta going to be? What's that? Yep. 3/5. Okay, what will tangent be? Anybody? 4/3. That's right. Okay, and then cosecant, secant, and cotangent, those will just be their circles. So 5/4, 5/3, and 3/4. Now, what quadrant, the only thing we have to be careful about, right, when we use those reference angles in the unit circle, the thing we have to be careful about, right, is that when we're in different quadrants, some trig functions are positive in certain quadrants and sometimes they're negative in certain quadrants. So what quadrant are we in right now? 2. And what trig ratios are positive in quadrant 2? We know in quadrant 1, right, all trig ratios are positive. What trig ratios are positive in quadrant 2? Sine is positive, and its reciprocal cosecant, right? Quadrant 3, remember what trig ratios were positive here in quadrant 3? Tangent, right, and its reciprocal cotangent. And then in quadrant 4, cosine, right, and its reciprocal secant. Okay. And so in this case, only sine and its reciprocal cosecant should be positive. Everything else we need to make negative. So just negative 3/5, negative 4/3, negative 5/3, negative 3/4. Okay. Quadrant 2, only sine and its reciprocal cosecant are positive, so all the other ratios then need to be negative. Okay. And it kind of works out that way too. So, and I know this isn't like good math necessarily since we're talking about a triangle here, but if we labeled this bottom of the part of the triangle here, if we labeled the bottom part of that triangle as a -3 because it's like talking about like the x coordinate there being a -3. Then if you did your trig ratios, right, it would be adjacent, that -3, or cosine of theta would be -3 over 5, which is what we get there, right? Tangent of that theta would be opposite 4 over the -3, so negative 4/3 or 4 over -3. So it would work out, is what I'm trying to say there. If you actually left that 3 as a negative, even though it doesn't make sense for like a length to be negative, if you still made that -3 since it was a -3 x coordinate there, you would end up getting all of these ratios correct without having to go back and think, okay, which quadrant has, which trig ratios are positive. So that would kind of take care of itself. Or again, you can just remember the little, all students take calculus or however you want to remember it there for your different quadrants where they're positive. You can also remember the quadrants where, you can also remember which one's positive and negative based on the fact that, remember that sine corresponds to the y coordinates. So in the first and second quadrant, your y coordinates are always positive. So sine will always be positive in the first and second quadrant because the y coordinates are positive, right? Sine will always be negative in the third and fourth because the y coordinates are negative, right? Cosine will always be positive in the first and fourth because cosine corresponds to the x coordinates. X coordinates are always positive in those two quadrants. Whereas in second and third quadrant, the cosine will always be negative, and it's reciprocal as well. And then tangent, right? Tangent, it will always be positive in first and third because in the third quadrant, both sine and cosine are negative, and tangent is sine divided by cosine, so a negative divided by negative will make it positive there too. Okay, same thing for its reciprocal cotangent. Okay, so cosine's positive in these two, sine's positive in these two, and then tangent, its reciprocal cotangent are positive in those two. Okay, so that's that. Any questions on anything? Otherwise, we're done. Okay, so all right, let me get you guys some practice then for this.